another one is boiling. Okay, we are going to differentiate evaporation and boiling. These two concepts are present in your textbook. Okay, evaporation, it is the process of gradual transformation of water into water vapor. Okay, gradual transformation of water to vapor by gradual transformation. If any water or any liquid is converted into gaseous state by gradual transformation without any supplying of heat, we call this as evaporation. Similarly, for boiling, if a body is converted from liquid to gases or water to vapor, after reaching its boiling point, then that kind of conversion we call it as boiling. Evaporation is conversion of liquid to vapor, liquid to gases at any temperature and any pressure. Similarly, boiling is the conversion of liquid to vapor or liquid to gaseous state or water to vapor after reaching its boiling point. The main thing is it should reach its boiling point. Here the liquid need not to reach its boiling point. So how does the evaporation occurs? So if you observe one thing, if you take one tub and completely fill it with water and take one jug with up to the brim, take one mug and a tub and fill the water up to the brim. If you observe and both are kept under the fan, then automatically you can observe that water present in the tub evaporates very fast when compared to the water present in the mug. Why? Because the water which is present on the tub, which is present inside the tub and is reacting more with the air, than the water present in the mug. That means here the water gets or absorbs energy from the surrounding air and its average potential energy gets increased, and then it reaches to then automatically it will be converted into vapor. In evaporation, water molecules, surface water molecules, in evaporation procedure, surface water molecules will absorb energy from air. Okay, will absorb energy from air and increases its average potential energy. Here, by supplying heat, and after reaching boiling point, the water is converted into vapor. That procedure we call it as boiling. Here, how does the evaporation occur? Is the surface water molecules will absorb energy from the air and increases its average potential energy and gets automatically converted into vapor. Okay, there the boiling. Here we are going to supply the heat, then it will increase its temperature, and after reaching the boiling point, still if we supply the heat, then automatically the water will be converted into water vapor. Next, evaporation and boiling. So, boiling The boiling mainly considers the boiling point. The boiling mainly occurs after reaching the boiling point. So we can change the boiling point of any liquid. We can change the boiling point of any liquid. That is by changing temperature. Sorry, not by changing temperature. By changing pressure. By changing pressure, we can change the boiling point. That means if we apply some pressure on the liquid, okay, surface of the liquid, automatically the boiling point will changes. This is the main reason why we are using pressure cookers for the cooking. If you observe the pressure cooker will get or will cook the food very fast when compared to normal vessel. Why? Because the pressure cooker locks the air present inside it. The pressure cooker will lock the air present inside it, and the air also absorbs the air and gets increases. We know that the increase in size or the change of size, the increase in size is far greater for the airs than the normal liquid and gases. That means the increasing in size or the rate of expansion is very high for gases when compared to liquid and solids. So, since the air is present at top region of the pressure cooker, if you supply heat to the, let's discuss this through the diagram itself. Assume this is a pressure cooker. These are the food materials, and up to here, this is the water level. And if you supply heat to it, first the water gets heated. After that, the heat will be transferred to the air. Then what? The air will start expanding. The air starts expanding, and after expansion, it will be tries to come away through the vessel, but the vessel has been locked, and it won't open up to a certain amount of pressure is applied. Hence what happens? The expanding air will start applying pressure on the surface of the water. The expanding air will apply pressure on the surface of the water. Hence the applied pressure of the water starts increasing. Automatically its boiling point also gets increased. Okay, automatically its boiling point also gets increased. That's why if the boiling point of the water gets increased, the heat storing capacity of the water also gets increased. Hence, more amount of heat is stored in the water, and this stored heat is supplied to the food materials present inside the water. And this is the main reason why the food materials present in the pressure cooker heats fast or cooks fast than compared to the normal vessels. So, the rate of evaporation depends mainly on three factors. One is surface area, second one temperature of liquid, and third one is amount of water vapor. Amount of water vapor present in surroundings. Present in surrounding air. Okay, the rate of evaporation always depends on these three factors. And if the pressure is more inside the room, automatically the rate of evaporation gets decreased. One of the factor is pressure also. Here also pressure plays a key role. If the applied pressure is more on the water, up to your textbook only three factors, but pressure is also one of the important factor which plays a key role in the evaporation, which plays a key role in the evaporation. So if pressure applied on the water is high, then automatically it won't get evaporated. If the applied pressure is very low, automatically it gets evaporated. If you consider water is present on the moon, but a huge amount of water vapor is present in the space, but the water vapor is not present in terms of water. That means ice is present in the space, but not in terms of ice, in terms of water vapor. Why? Because due to very low pressure, automatically the boiling point has been decreased very enormous way, such that at 0 degree or at minus degree temperature itself, the water will be present in terms of water vapor. At minus 40 degrees, normally the water will be present in terms of ice. In space, the water vapor is present in terms of, the ice is present in terms of water vapor due to low pressure. So, if we apply pressure for water, the boiling point increases, and if pressure decreases, boiling point decreases. So boiling point is directly proportional to applied pressure. Boiling point is directly proportional to applied pressure. So boiling point is directly proportional to the applied pressure. So this is the reason only for water. For some liquids it may decrease, for some liquids it may increase. So if you apply pressure on any body, then automatically its temperature may increase. We can increase the temperature of any body by applying the pressure also. If pressure on the body increases, then the temperature of body also increases. This is one of the factors which you need to consider it on. Okay? If the pressure of the body increases, then automatically the temperature of body also increases. Consider two ice cubes of same size and present in the same room. One is kept somewhere, another one is kept somewhere. If we apply pressure only at the second ice cube, then you can observe that second ice cube melts fast when compared to the first ice cube. First ice cube is just left away, we haven't touched it. But the second ice cube, we have applied some pressure on the ice cube. What happens? Due to applied pressure, the internal temperature has been increased, which results in fast melting. That is the main reason. If you apply pressure on the body, then automatically its temperature increases. So the melting point of water will also. So this is about the boiling one. For boiling, we need to know one formula. Okay? Heat required for boiling of water, Q is given by M into latent heat of vaporization. Okay? Where Q is equal to heat, M is equal to mass of liquid, LV is the latent heat of vaporization of liquid. So for boiling, you need to consider these three factors. Okay? The amount of heat required for boiling of any liquid is given by Q is equal to M into LV, where M is the mass of the liquid, LV is the latent heat of vaporization of the liquid.